And we have here a circular motion question, our grade 12 physics class, number 9 from your worksheet. If a 620 kilogram race car takes 15.2 seconds to travel at constant speed once around a circular track of 50-meter radius, what are the centripetal acceleration of the car and centripetal force exerted by the track on the car's tires? So remember, to get around a corner, there has to be a centripetal force acting towards the center of the circle. In this case, that force comes from friction. So let's get started, and we'll get her done. Writing down what I have the mass, 620 kilograms. Time to go around once is period, 15.2 seconds. Radius of that track is 50 meters. We want to know the centripetal acceleration and centripetal force. Acceleration is mv squared over r. Sorry, acceleration is v squared over r. Centripetal force is mv squared, mass times acceleration. See, it doesn't matter what you're working with, Newton's second law holds. Force is mass times acceleration. Right, so we don't have v, we can get that. So we'll do that first rather than doing a bunch of substitutions with equations. The first thing I'm going to do is calculate v. V is 2 pi r, the circumference of the circle, divided by the period, the time it takes to go. So we get meters per second out for that one. Oh, page down. Sorry, I know it's getting a little wavy here. Still with me without getting sick. We'll calculate velocity. V equals 2 pi r, 2 pi times radius of 50, period of 15.2. Velocity comes out to be, let's calculate that up, 2 times pi times 50 divided by 15.2. That gives us a velocity of 20.7, that's a 0, 20.7 meters per second. So now with the velocity, I can figure out both acceleration and centripetal force. Looks like I have to re-rotate the board. Alright. So acceleration equals velocity squared over r, which is 50. So centripetal acceleration is 20.7 squared. This is about 427 divided by 50 gives us 8.54 meters per second squared. So centripetal acceleration is that. Centripetal force is mass times the centripetal acceleration, or mv squared over r. So rather than doing the calculation all over again, it's the mass. And in this case, which was 620, I believe. Yep, 620 times our answer of 8.54. So centripetal force comes out to be about 5,300 newtons, making that thing turn around the corner. Of course, the faster you go, the greater the force required to make you turn. All right. So I'll be doing these questions like that, where I'll start from the beginning, work through with the equations that we know, and then rather than just substituting these numbers into one formula, work through the mathematics and figure out how to get all these problems done.